देखो मेरा मेरा चेहरा आ रहा है। ये थे वो वाला दिख रहा होगा, उसको हटा दिए ना, मेरे पे तो नहीं दिख रहा है। So, good morning, everyone. So, welcome to Physics by Physics. So, in this live session, again, we will solve some more question related with electromagnetic theory of July 2025 NET-JRF paper. I have already discussed some problem. Now, let's see some other problems. Okay? So, I think we have discussed, let's see. We have discussed this question. Up to this point, we have discussed. Now, see next one. Yes, this also I have discussed in last session. Okay, let's start with this particular question. Okay? Yes. So first, read the statement of the question. What is given here? The charge density of an electron cloud of a hydrogen atom is given by. This charge density is given as a function of R, where A is some characteristic length. The potential energy due to interaction between the proton that is sitting at the origin and the electron cloud. Interaction energy. So you have to find the interaction energy between the proton and the electron cloud. So what we will do, we will find the potential at the center due to electron cloud, and then their interaction energy or its potential energy is given by simply proton charge into V at the center. So in this case, this interaction energy U is given by simply proton charge is plus E, and then you should multiply with potential at the center. Potential at the center. And this potential at the center is due to electron cloud. So it's a charge density is given. So how to find the potential at the center? So we will use this result, that is 1 by 4 pi epsilon naught. We will take, let's see, this will be the integral of rho by r d tau. So d tau in spherical symmetry is, this is, we will take it as 4 pi r square dr. So you can write it as 1 by 4 pi epsilon naught this will be rho by r into 4 pi r square dr, and then you should integrate it from 0 to infinity. So that will give you the potential at the center. So this will give you 4 pi will cancel out, and you will get 1 by epsilon naught 0 to infinity r rho dr. Let's find this value. So if you substitute the value of rho here, that will give you potential at the center is given by, I'm taking this term common, minus E by 4 pi epsilon minus 8 pi a cube. So this will give you minus E by, you have 8 pi epsilon naught a cube 0 to infinity, and this becomes r exponential minus 1 by a into r dr. Okay? Now, in order to solve this integral, you should use one standard integration result, and that is, just use this integration result. 0 to infinity x power n e power minus alpha x power m dx, where n and m are some integer. So this standard result is 1 by m. This is gamma n plus 1 by m. Many times you have to use this integration result. So must remember this particular form. We have to use this result. So in this case, if you want to use this formula here, you have to take n is equal to 1 because r power 1, m is equal to also 1, and alpha is 1 by a. Alpha is 1 by a. Okay? So what you will get here, minus e by 8 pi epsilon naught a cube. So this is 1 by 1 gamma 1 plus 1 by 1 by alpha is 1 by a power 2, 1 plus 1 by 1. So, and gamma 2 is simply 1. So this is a square. So you have to, this becomes a square. So if you multiply with a square, this is minus e by 8 pi epsilon naught a. This will be the potential at the center. Take gamma 2 is 1. Okay? So you will see here minus by 8 pi epsilon naught a cube into a square. And once you know the potential, what you will get? This is minus e square by 8 pi epsilon naught a. So which one is correct? I think here D option is correct. Is it clear? So in this way, you can find the interaction potential energy due to the interaction between the proton and electron cloud. You can call it as a interaction energy also. ठीक है? चलो. So let's see next question. Let's move on to the next file. Just give me 1 minute. Give me 1 minute. And so we have solved this question. This question we have solved. Yes, next one. Yes, see this question. Yes. So in this question, this is the figure A. There are two identical cubes that are shown in figure A and B. This is A, this is figure A, and this is B. The magnetic field at the center in A is given by B naught. So what will be the magnetic field? Because it's a current loop, and in this current loop, according to right hand rule, if this is the direction of current, loop is in xz plane. So magnetic field is in the y cap direction. So this magnitude y direction will be y naught and magnitude will be b naught. So this is given. So due to this particular loop, you know the magnetic field is B naught. This information is given in this question. Now the magnitude of the magnetic field at the center of the cube. In this case, what will be the magnetic field when current is flowing in this way? So now we will use the symmetry of the problem. And what we will do, we will consider similar loop, and you will see, and if you superimpose these three loop, you will get this particular symmetry. So what are the loop? Let us first consider this as a loop 1. So I am taking this upper one as a loop 1. So let's see, this will be the direction of current. This is loop 1. This is loop 1. So if you are considering a complete loop, so this will be a complete loop like this. So call it as a loop 1. And another loop is, you can think of this as a loop 1, a loop 2. Let's say this is loop 2. This is loop 2. This is loop 2. And then there will be loop 2, because loop 2 will also complete the current. So due to loop 1, current is in this direction, and loop 2, current is in opposite direction. So they will cancel each other. And if you see this particular loop, let's say this is loop 3, this is loop 3, this is loop 3, and here you will get loop, this direction will be loop 3. So in this symmetry, if you are considering three different loops, and if you superimpose, what will happen? This will cancel out. Okay? This will also cancel out, and this will also cancel out. So what you will get? You will get this particular current direction only. So this is the resultant of these three loops. Yes or no? So if you see, let's say this is the center O. At the center O, if you want to see the direction of magnetic field, so due to loop 1, current is flowing in this direction, loop is in the XY plane. Loop is in XY plane. According to right hand rule, that direction of magnetic field is Z cap. So we will write it as this direction to be, this will be magnitude and direction to be Z cap. Let's say this is center O. This is loop 1. So you can call it as B1. This field is B1. Then you are taking this as a loop 2. So this is the direction of current. Current is flowing in this direction. So according to right hand rule, this direction is Y cap. So B2 is given by B naught Y cap. And if you are considering a third loop, current is flowing like this. So this will be the magnetic field B3, and this will be in the minus X cap direction. So at the center, if you see at the center, resultant B is given by B1 according to superposition. So that will be minus B naught X cap plus B naught Y cap and plus B naught Z cap. This is B. So if you want to find the magnitude of B, let's calculate what will be magnitude of B. So this will be simply under root B naught is square plus B naught is square, and that will be under root 3 B naught. Under root 3 B naught. So option A is correct. Is it clear? So that's why this information is given, and using the symmetry of the problem, we have calculated the magnetic field. So note it down. So let's see the next question. Now you can see we have solved this question. Now this is the next question. So let's read the question first. A gas of electron with no source of scattering, there is no scattering here, no source of scattering, is placed in an electric field E is given. Yes. So let's see slightly. I think now it is visible. Yes. So in this question, so there is a no source of scattering and electric field is given. In direction is I cap and K cap. Vector is E power iota omega t I cap plus K cap. Magnetic field is given in the K cap direction, where E and B are constants. E and B are constants. The frequency at which the conductivity of Z direction, conductivity in the Z direction given by the ratio of the current and electric field. This is given both in the Z direction. In what condition they will diverge? Means you have to see G, the ratio of the current and the frequency at which the conductivity sigma. You have to see what will be sigma. Sigma Z is given by Jz by Ez. Under what condition sigma Z will tends to infinity? How it depends on omega. So you have to find the sigma Z dependence on omega, and then you can see under what condition they will diverge. So what we will do here, because there is a no scattering, so electron will experience, since there is no scattering, so you can use the Lorentz force law. So that is given by m dv by dt. Same equation can be used. This is minus E plus V cross P. So electric field is given, B is given. What will be V? V I am taking as, let's say, this V as a function of time. V as a function of time, you can take it as V naught vector x, or you should just take it as a z component, x, y, z. It has general, V is a constant here, and I am taking in the same form, e power omega t, where V is given by, V has Vx I cap, Vy j cap plus Vz k cap. Is it clear? So from here, what will be V cross B? What will be V cross B? Because B is given in the k cap direction. So if you are taking this vector V, let's see, this will be V e power iota omega t cross B k cap. So if you take I cap cross k cap, that will give you minus of j cap. So this is minus Vx j cap. I will take, and j cross k cap will give you plus Vy iota cap, and k cross k cap will be 0, exponential iota omega t. So you can write this as a V cross B. Yes or no? So finally, this becomes m V is given as iota omega. This is V. V is a constant here. So exponential iota omega t, and that is minus of E. E is given as E iota omega t I cap plus j cap. And what is V cross B? Exponential. Here B is also there. This will be B. So this exponential iota omega t B minus Vx j cap plus Vy I cap. Okay? This will be the value. Now exponential will cancel out and you will get m iota omega V. This will be given by minus E I cap plus j cap, and then you have a plus B minus Vx j cap plus Vy I cap. So we are because we are interested in Z component only. So if you equate Z cap component, what you will get? So this is here you have I cap plus K cap. E is given as E is I cap plus K cap. This will be not J cap. This is K cap. So if you see there is only one this K cap. So if you write the Vz component, that will be simply minus E into E, or Vz is given by minus E by m iota omega. Okay? So this is the Vz component. Yes or no? Then current density having Z component only. So I am writing minus Ne Vz. So if you multiply with Ne, N is the number per unit volume. So this is Ne square E by m iota omega. Now sigma z I am writing it as Jz by Ez. So I am writing the magnitude only. So if you divide it by Ez is E, let's write the magnitude. So that will be for Z component only. So this is Ne square by m omega, m iota omega. So it means it is inversely proportional to omega. So as omega tends to 0, this tends to infinity. So what they have asked, that the frequency at which the conductivity in Z direction will diverge. So omega tends to 0. It means option A is correct. Okay? So please note it down. Chalo. So now let's see one next question. Yes. So first you have to read the statement that in a particular inertial frame, electric and magnetic field is given. And just see both this, they are in the same direction, x cap direction. Then which of the following statement is true? So E and B are parallel here because they are in the same direction. So you know that for EM wave, what are the Lorentz invariant quantity. So for E electromagnetic waves, the Lorentz invariant quantities are, one is, call it as I1, and that is given as E square minus C square B square. And second one is I2, and that is E dot B. They must be Lorentz invariant. So I1 and I2 will not change. So in our question, this E and B is given. So what will be E1, I1 here? I1 is E naught square minus C square E square by 4C square. This will cancel out, and 4 minus 1 is 3 E naught square by 4. So that will be I1, and that is non-zero. And what will be I2? I2 is, because E and B are parallel here, so x dot x will be 1. So what you will get? This is E naught square by 2C. That is also non-zero. So both I1 and I2 are non-zero. Now see, in this question, you have to see whether E is 0 or B is 0 or not. So if E is equal to 0, what will happen? I2 will be 0. So, but I2 0 means what? It should be 0 for all frames. But here you are getting I2 is non-zero. It means that is not possible. Similarly, if you take B is equal to 0, I2 will be 0, and that will be 0 in all frames. But here I2 is non-zero. It means both E is equal to 0 and B is equal to 0 is not possible. Because if E is equal to 0, then I2 is 0 in all frame. And also, if B is equal to 0, then I2 is 0 in all frame. But here you are getting I2 is non-zero. So what? So it means there is no inertial frame. There is no inertial frame whether E is equal to 0 or B is equal to 0. So best option is B1. There exists no inertial frame whether E is equal to 0 or B is equal to 0. If that is 0, it must be 0 in all frame. So from the given condition also, you will get 0 value. Okay? So these are the questions related with the electromagnetic theory of July paper. Clear? So note it down. So that is all about EMT questions. Now in next session, I will discuss the mathematical physics question of same paper, July 2025. ठीक है? चलो फिर. Okay. Thank you everyone. Thank you.